All right, I'm going to show you transformations to logarithmic and exponential functions. This should be pretty easy because really, you guys have seen transformations 5 times by now. So it's just kind of the same thing. So when I'm looking at the log parent function, um, whenever you're doing a log parent function, they kind of have to tell you what the base is on the parent function that they're giving you. So it'll say like log base 3 of x, and then they'll say, tell me the transformation to the function log base 3, and they'll do other stuff to it, okay? So we've looked at all this stuff before. Remember, anytime we multiply by a in the front, that's going to be our vertical stretch and compression, and it's also going to reflect it across the x-axis. So we're looking at, what is this number out here? Is the absolute value of a greater than 1 or less than 1? And then is it positive or negative? So that still does the same thing. Inside of here, your b is going to be next to the x inside of the log, and it's still the same rule, 1 over b. So remember, our b is going to be our horizontal stretch or compression, and then it's going to reflect it across the y-axis. And then remember that h is moving it to the left or to the right, and then k is moving it up and down. So there's nothing really changed here. We've seen all this stuff before. What I'll give you is I'll give you stuff that says, tell me the change to this. We're still going to use this parent function. Don't forget about your b, that you have to factor it out. So just because there's a 2 right here doesn't mean, or because there's a 2 right here makes this movement not 2 units to the left, or sorry, not 4 units to the left, but 2 units to the left. Meaning we have to change this to be like this to really see what's going on. So this 3 is greater than 1, so it's going to be vertically stretched by a factor of 3. This 2 is 1 over b equals 2, and we've done this a lot, so that's 2 over 1. We multiply to get it, and we get 1 equals 2b. Divide by 2, and we get b equals 1/2. So because b is less than 1, it's going to be horizontally compressed by a factor of 2, or 1/2. And then this 2 is going to move it to the left 2. So that's what we're looking for on these guys. You guys have done a lot of stuff with this, so it shouldn't be anything new. With exponential, it's kind of the same thing. They have to give you there's not like one parent function to go off of, so they have to give you a baseline function. So if it tells me something like, here's this, tell me the change to the parent, to this as the parent function. Same rules. A is in the front, so a times 2 to the power of x. A is going to be my vertical stretch or compression. It's going to reflect it across the x-axis. And then up here in our exponent is going to be 1 over b, x minus h, and then plus k. So b again is going to be our horizontal stretch or compression, and then reflected across the y-axis. H is moving it to the left or to the right, and k is moving it up or down. So if they give me this 3 is going to vertically stretch it by a factor of 3. This 4 is going to horizontally compress it by a factor of 4, or 1/4. Because I have to divide out the 4, it's really going to be x plus 9 over 4. So this is going to be moved to the left 9/4 of a unit. And then this 7 is going to move it down 7. So very, very, very simple. Same stuff that we've already been doing. We're just looking at it, the equation's a little bit different. When you have questions on this, let me know.